rod cut problem. So remember, the objective or the input of this computational problem is basically a class array like this, and plus n is the plus an integer n, which denotes the length of a rod that we are giving. And our objective is to find the optimal cut of this rod whose length is n inches, and we want to maximize the total revenue making from that. And so first we went over a simple solution, which is to enumerate all the possible ways of cutting the rod, and then calculate the revenue for each of these ways. And but unfortunately, we find that this will lead to an exponential complexity, or we call it NP hard. So, and we say that with an NP hard or with an exponential complexity, as long as the problem size reaches 100, will take us more than 1 billion years. Actually, it's 30 billion years to finish the calculation. And then, so we learned a mathematical formula. So over here, which tells us, or which here in this mathematical formula, Rn denotes the maximum revenue for rod of certain length n, and Pi is the price that you can get by selling a rod whose length is I. So so then we learned this mathematical formula. Basically, it asks us to try all the ways, all the possible places of the leftmost cut, and say, okay, whichever gives us the highest revenue. So and also we say that, okay, so even though this mathematical formula is really beautiful, but still it leads to exponential complexity. It does not reduce the workload for us. So we learned the mathematical solution, which is over here, a dynamical programming solution, which is to say each time when we calculate the optimal solution for a rod of certain length, we store it in an array, and next time if we need it, we just retrieve it from the array. So that is how we reduce the complexity of the algorithm from exponential to n squared. And so with the help of dynamical programming. Okay, so this is what we covered last week. And so today, before I step into the second problem by using dynamical programming, I want to talk about the essence, or so definitely want to know for which kind of problems you should use dynamical programming. Okay, so the thing is that, okay, if you see a problem which shows the optimal substructure property, you should definitely consider using dynamical programming. So what is the optimal substructure property? This is in the plain language, it means that the optimal solution to a big problem incorporates solution to related sub-problems, okay, which we may need to solve independently. So which means that the optimal solution to a big problem incorporates the optimal solution to a sub-problem, and this is called the optimal substructure property. When you see such property, so in a problem, you should have the instinct saying that, okay, I have to use dynamical programming to solve this problem. So how do we know if a problem shows this optimal substructure property? It is here. So on the left-hand side, we have the optimal solution to a problem whose size is n, correct? Correct?
Yeah, that's correct.
Okay, and then on the right-hand side, we have the optimal solution to a problem whose size is n minus I. Correct?
Yeah, that's right.
So because I is in the range from 1 to n, then we definitely know that I is less than n, because I is a value larger than or equal to 1. So n minus I is definitely less than n, correct?
Yeah.
So basically, this says the optimal solution to a problem to a size n problem, incorporates the optimal solution to a size n minus I problem, or problem. Okay, so this is sub problem. So this is basically the optimal substructure property. And so if you say, okay, if you say an equation where the optimal solution to a bigger problem is displayed on the left-hand side of the equation, whereas the optimal solution of a sub problem is appears in the right-hand side of the solution, we should definitely consider using dynamic programming, because this is just the optimal. This is the optimal substructure property, where the optimal solution to a big problem incorporates the optimal solution to a small problem. Okay, so any question? No? Does it make sense?
No questions.
Okay, this may sound like very abstract for you, but we will, when we learn more problems that which we use dynamic program to solve, they will make more sense to you. Okay, so so today we're going to learn another problem which can be solved by using dynamic which can be solved by using dynamic programming, and this problem is going to make more sense to you. So it is definitely more intelligible for you. Okay, so the problem is called longest common subsequence problem. Longest common subsequence problem, and the input of the problem is basically two strings, and we want to find the longest common subsequence between these two strings. What is a longest common subsequence? So for example, if we have x and y over here, then the longest common subsequence is basically BCBA, because B appears in x in the first input string x. C also appear in the in x, and B shows in this in x, and A shows in this x shows in x. Okay, and also B, C, B, A also shows up in y. So here in what we do here is the relative order of the characters in the longest common subsequence, but they don't have to. The characters in the longest common subsequence does not have to appear consecutively in the input strings. As long as they follow the same order, it is fine. CBA in x and BCBA in y. So we say that BCBA is definitely a common subsequence between x and y. Right?
Yeah.
Okay. So the problem is that, is this the longest one? Okay. Can you find a longer common subsequence between x and y? Let's say, can you find a length 5 common subsequence between x?
Quick question. I know that you said that they don't have to be, I guess, in order, like, so it doesn't have to be B, C, B, but it has to be like in that order. So would we be able to add the A, because the A was in X and the A is in Y also? Another A is?
So can you say that, can you propose the longest common subsequence, BC, BAA, or?
Yeah, we could.
BCAA.
But that's not, okay, so it's not, because that's not in order. Oh yeah, no.
Okay, so we got BCBA, but not another A in X, right?
Yeah, okay.
So this would not work, correct?
Yeah. Mm-hmm.
Okay, we should forget about it. Can you find a common subsequence which is longer than this one?
No, because that's the longest one.
Yes, this is the longest one. So we cannot find anyone that is longer than this one. And so we call it the longest common subsequence between X and Y. Okay, so what is important over here is that you need to remember that the characters in the longest common subsequence does not have to appear consecutively in the input strings. As long as they appear in the same order, it is fine. Okay, so any question with regard to of this problem, longest common subsequence? No? Okay, then let's look at another input strings, okay? Another pair of input strings, okay? So here we got S1 and S2. And basically we want to find the longest common subsequence between them, okay? So here, so what does S1, S2 represent?
Chromosomes, I think.
Sorry?
Is it chromosomes? Like,
I'm not sure.
I think they pair up with each
I
other.
never heard that term before, but
Okay.
this is our DNA sequence.
Yeah. Okay. Yeah.
Right? This is our DNA sequence. So the very famous application of common subsequence, longest common subsequence, is to detect the similarity between two DNA samples. So which is widely applied in criminal justice. Basically, if you take the blood from a possible, say, if you take some blood from the criminal scene, and then you take a blood sample from a suspect, you compare how similar are they. If they're pretty similar, you are sure that this is the person who did that, who made that crime. Okay, so here we can say that the longest common subsequence between these two DNAs are okay. Then our objective in this problem, our objective is basically to find the longest common subsequence between two input DNAs. Okay, so and then if we formalize the problem, it is like this: we're given two sequences, X and Y. So here let's just simplify the problem. Now we do not target at, we do not want the actual sequence. We want to find the length of the longest common subsequence, okay? So given two sequences, X and Y, and we want to find the maximum length of the common subsequence, basically which is the length of the longest common subsequence between these two input strings. So the output should be an integer. Any questions so far? No? Okay. So, and then I'm going to maybe spend 10 minutes on something that is really mathematical for you. Okay. So if you are not interested in this part, or if you have difficulty in understanding this part, it is fine. It does not it does not prevent you from being able to understand the pseudocode that we are going to talk about. But if you can understand it, you will feel the beauty. Okay, so the mathematicians, the mathematical guys, they propose, they prove this theorem. So the theorem is this. Okay, let X and Y be two sequences, and let Z be the longest common subsequence between them. So they basically propose this. Okay, if xm equal to yn, which means that the last character between these two strings match, then Z keep so then we basically include the last matching character between X and Y, included we basically include that last matching character in the longest common subsequence, which is the last character in the longest common subsequence over here. And then we're going to take the longest common subsequence between the first m-1 characters of x and n-1 characters of y. So otherwise do not match, then we need to do something else. So I'm just going to explain this mathematical formula for you using a graph or using a diagram, okay? So suppose here we have x with x1, x2, x m-1 and xn, and then we got y. So y1, y2, yn minus and yn. So here you can see that we have, sorry, this is xm, not xn. So here you can see that we have two strings with x having m characters and y have n characters. But just align them. They don't have to have the same amount of characters, but I just align them for the purpose of explanation. So what does this theorem says is this, okay? So if the case one is that this is the first case, if the last two characters match, okay? If the last two character match, if xm equal to yn, so basically the last character of x and matches the last character of n, so then the longest common sub. So what we care about most is z, okay? Is z, which is the longest common subsequence between x and y. What we do is that, okay, we're going to include this matching character as the last character, as the longest common subsequence between x and y. So this is the LCS between them. So we call it z, okay? So we're going to include the last matching character in so over here, and then we're going to take the longest common subsequence between the first m-1 characters of x. So here it means that we include all the characters, all the first m-1 characters of x and y n-1 y, and then take their longest common subsequence, okay? We are going to take the longest common subsequence between them, and then plus the last matching character. So this will be the longest common subsequence between x and y. Any question? Any question for me?
No questions.
Is that clear? I'm just wondering.
I would, me personally, I would have to see it in action, like the code and everything, like we have to go through.
Okay, yeah. So let me explain it in this way, okay? Suppose that we have a list of men and a list of women. So we have let's say we denote x with men, okay? X1, 2, x m-1 and x m. So we got this number of men and women, okay? So y1, y2, yn-1 and yn. So we basically want as many of them get married as possible. We basically do a match, okay? So the thing is, you can take it in this way, okay? If the last man and the last woman, they say, okay, they want to get married, okay? We are going to say, okay, congratulations, and we're going to we're going to match as many couples from the. We're going to exclude this couple because they are already married, okay? And let the first m-1 man and the first n-1 women. We try to match as many of them as possible to get married. So the total number of married couples is going to be 1 over here. So we got one couple over here, plus let's say we got probably S couples married over here. So the total amount of married couples is going to be S plus 1. Is that fine?
Yes.
Yeah.
Okay, so this is basically what this does. Okay, so here we're not talking about getting married. Okay, we're talking about match. Okay, so if the last character of X and the last character of Y matches, then we're going to take it as a match, include it in the longest common subsequence, and then we're going to look at subsequence, exclude this matching pair, and we're going to ignore this part and only work on the first n-1 characters of X and the first n-1 characters of Y. Take the longest common subsequence of them, and plus the last matching character. Make sense? Okay, so now I can understand it.
Yeah.
Yes.
Yeah.
Okay, so the second case is here. Okay, the second case is, I'm going to explain the second case. The second case is this. Okay, if the last character does not match. Okay, if the last character does not match, say here, for example, if we're trying to match, let's still use the men and women problem over here. Okay, we say, okay, let these two last man and the last women hung out. Last woman hung out. They after a couple of days, they said we're not a match. We're not going to get married. So they are not going to marry. They're not going to get married. So what we do is that, okay, so we say, okay, we have to either exclude the last man, or we either exclude this guy, the last man, from the matching team. Okay, say, okay, we're going to take X. We're going to exclude this man, and then match the rest of the men with all the women. So because it match, we have to exclude either of them, either this man or either this woman. So okay, or so this is the first case, or we just exclude this woman because she is a problem too. She could be the problem too. So so we basically exclude that woman and the last woman, and then let okay, so it's like we either exclude the last.
Hello.
Professor, you're muted.
I think he froze out or something.
Frozen.
Yeah, he's frozen.
Married.
No,
here
he's
we
his
can,
Facebook.
sorry?
He's
You froze for a second.
Okay, I'm sorry.
yeah, we couldn't hear you for a little.
Okay, so how about now?
We
Yeah.
can hear you right now.
Yep, we can hear.
Okay, so okay, let me repeat that. Okay, the thing is that, okay, if the last man and the last woman, they said, okay, we are not going to get married. So then our solution is that we are going to try to either exclude the last man from the matching team. Okay, we say that goodbye, because here you can see here we're excluding the last man, and then let the rest of the men match with all the women. Okay, that is this solution. For example, if we go this way, we got S1 couples married, and or say we say, okay, the last woman could be also a problem. So what we do is that we let all the men try to match with by excluding the last woman. We try to let all the men match with the first n-1 women, and then over here, let's say we got S2 couples match. And so what we do is that, okay, from here we're going to get the max of them. Okay, if we go for this solution, we can get S1 couples married, or if we follow this solution, we can get S2 couples married, and then we're going to take the the best way. Okay, so whichever gives us the more couples getting married, we choose it. Make sense?
Yeah.
Okay, so this is what we do. Okay, so and over here, this is what we do. So again, we're not talking. Okay, over here we're not talking about like man, woman getting married. We're talking about the match, the character match. If the last character of X and last character of Y does not match, what we do is that we're going to take the LCS between the first, by excluding the last. Either we'll try to either exclude the last character from X and match it with all the characters of Y, or we're going to exclude the last character from Y and then match it with all the characters of X. So whichever gives us a longest common subsequence, we'll take it. Make sense?
Yes.
Yeah.
Okay. Okay. So then this is the what does this mathematical formula tells us. So if the last character match, then we include it in the longest common subsequence. Otherwise, we either exclude the last character from X or the last character from Y and do another match and say whichever is longer. Okay, so then this is the strategy to find the longest common subsequence. And over here, people just design. So following that theorem, the mathematician guys just design another a mathematical formula, which is really beautiful. And this formula can help us to find and to tell the length of the longest common subsequence between a pair of strings. So basically Cij, so here what we need to know, what does Cij mean? Cij means the length of the longest common subsequence, the length of the longest common subsequence between the first I characters of X and the J characters of Y. Okay, so here it's like we're going to consider, so for example, if this is X, we have X1, X2, Xi plus 1, and then Xm minus 1 and Xm. So Xm, so we have Y as this, Y1, Y2, Yj plus 1, Yn minus 1, and Yn. Okay, so here Cij basically tells us the length of the longest common subsequence between the, it's like we're going to only try to look at the first I characters from X and first the J characters from Y, and we calculate the longest common subsequence between them. Okay, this is what does Cij mean. Cij means the longest common subsequence, the length of the longest common subsequence between the first I characters of X and first J characters of Y. Is that clear?
Yeah.
Okay, so then so what this mathematical formula tells us is that, okay, so what basically tells us Cij, okay, if I is 0 or J is 0, we have Cij as 0. What does that mean?
Maybe if there's no, I guess, greatest common sequence or longest
Sorry?
common, there's no longest common sequence.
Yes, there is no long word to be more precise. The longest common subsequence is basically empty. There's no character in the longest common subsequence. But what does I equal to 0 or J equal to 0 stand for?
There's no subsequence.
Yes, if either X is empty or Y is empty. So if we are taking the long subsequence between an empty string with a very long string, okay, so the long subsequence of them must be empty, correct?
Yeah.
Okay, so that's why we have this. Make sense?
Yeah.
Okay, so then the second case is here, okay? If I and J are both larger than 0 and X and Y, Xi matches Yj, this is like the last, sorry, oops. So this is Xi and this is Yj, okay? So this is what we are here. So because now we're just working on the longest common subsequence between them, okay? So if X and if the last character of these two subsequences match, then as what we learned previously, we are going to take this we're going to take this matching character and calculate the longest common subsequence between the characters before them. Okay, so then this is what we got. So we're going to get this one matching character, and then plus the length of the longest common subsequence, the length of the longest common subsequence between the first I-1 characters from X and first J-1 characters from Y. Exactly the same as what we learn over we learn over here. The only difference is that we are replacing M with I and J with J. Make sense? Okay. So and then if it's not a match, if Xi and Yj is not a match, we are going to either exclude the last character from X, which is this case. We take the first I-1 characters from X and match it with all the first J characters from Y, or we're going to exclude the last character, the Jth character from Y. We're going to exclude this one from Y and then match it with the first I characters of X. So it's like if the last character of these two substrings do not match, we're going to exclude either one character from either string and say whichever gives and take the longest common subsequence, and then whichever gives us a longer one, we're going to take it. Exactly the same as what we learned over here. Again, the only difference is that we are replacing M with I and N with J. Okay. Okay. So is there anyone who understands the math behind this equation? So if you understand it, just type in 1. .5. Okay, cool. It's still pretty cool. 1. Okay. I say 2 1s and 1 0.5 and 0.5. Okay, so it's not essential for you to understand this mathematical equation in order to understand the following pseudocode. But the thing is that, okay, if you don't understand this equation and this theorem, it is fine. But what I ask you to do is that, okay, as long as you say this equation, you should definitely relate it to dynamic programming, because here you can see that we are talking about the optimal solution to a problem whose size is I and J, I by J. And here we're talking about the optimal solution to a subproblem whose size is I-1, I-1 by J-1. And here we're talking about the optimal solution to a problem whose size is I J-1 and I-1J. I minus 1 by j, okay? So here basically it shows that the optimal solution to a big problem incorporates the optimal solution to its sub problem. And this shows the optimal substructure property. Okay. This is what I asked. I require everybody to acquire. Okay. So you have to acquire this ability. On the left-hand side of the equation, we have the optimal solution to a problem whose size is I by j, whereas on the right-hand side, we have the optimal solution to a problem whose size is I minus 1 by j minus 1, or I by j minus 1, or I minus 1 by j. So this shows the optimal solution to a big problem incorporates the optimal solution to its sub-problem. And this is exactly what we discussed in the first part of the lecture, the optimal substructure property. Like over here, the optimal solution to a problem whose size is n incorporates the optimal solution to a problem whose size is n minus I. Okay, so no matter, this is really important. If you are doing your job interview, if you are doing a coding interview, the interviewer is going to help you to, if you cannot infer the equation, the interviewer is going to help you to reach this formula within 10 minutes, okay? But after that, after you say this equation, you should immediately say dynamic programming. If you don't say that, I mean, you don't have to continue the interview. So, okay, so that is really important. Okay, so next I'm going to explain the pseudocode based on this mathematical equation. And so this pseudocode basically translates the mathematical equation. So here, let's say the equation. So the LCS length. So this pseudocode basically calculates the length of the longest common subsequence between two input strings, which are x and y. So first we take the length of x and y as m and n, and then we create two new tables. Table basically means two-dimensional arrays. Two-dimensional arrays. So the first array is named B, and its size is m by n. Whereas for the second array, its size is different. C, its size is different. So first we have two for loops. For I from 1 to m, we assign 0. For j from 0 to n, we also assign 0. And the next, we do this. For I from 1 to m, for j from 1 to n, we have if xi equal to yj, we do something. And otherwise, else if we do something. Else we do something. And then finally, we just return C and B. Okay, so yes, this pseudocode looks very weird for us, because we say some arrows like this and this. Okay, I'm going to explain it now for you. So LCS x and y. So first we have m equal to x dot length and n equal to y dot length, and we have let b c two new arrays, new tables. For I starting from 0 to m, we have c I0 equal to 0, and for j starting from 1 to n, we have c0 j equal to 0. Okay, so this is the first part of the pseudocode. And here I'm going to have an example, x as a, b, c, b, d, b. We have x as a, b, CB, DAB. And then we have Y as BDCABA, BDCABA. Okay, double check that. Okay, CAB. Yes, that's correct. Okay, suppose that we have two input strings X and Y, and we want to find the longest common subsequence between X and Y. Let's follow the pseudocode. First, we have M equal to X dot length. So what is M?
6.
6?
5. Oh wait, no, it's 7. 1.
7, yes. X has 7 characters. So we have M equal to 7. So I'm going to write over here. We have M as 7. And next we have N equal to Y dot length. What is N?
6.
Yes. So Y has 6 characters. So we have this, okay? So next we created 2 new tables, B and C. So the index of B starts from the row index of B starts from 1 to M, and the column index of B starts from 1 to N. So what is the size of B? When you create the new array, how many rows and how many columns are there?
Maybe 7 by 7.
7 by 6, because N is 6.
7 by 6.
Okay,
Yeah,
so now I'm just going to write the X and Y a little bit down, okay, over here. So I'm going to B, A, B, C, B, D, A, B. Y as B, T, C, A, B, A. Okay, so I'm going to, so here first we create an array B whose size is say a 7 by 6. Okay, so we create a new array B. Okay, we got B. 2, 3, 4, 5, 6. Okay, so let's write its row index over here. 1, 2, 3, 4, 5, 6, 7. It's column index 1, 2, 3, 4, 5, 6. And then we create another table C, whose row index starts from 0 to M, whose column index starts from 0 to N. So what is the size of C? What is the size of C? How many rows and how many columns? Any idea?
8 by 7.
Yes, 8 by 7. It is because the row index starts from 0 to M, and M is 7. So we basically have 8 rows. And okay, similarly, we have 7 columns. Okay, this is C, and let's write its row index from 0. 1, 0, 1, 2, 3, 4, 5, 6, 7. Column index from 0 to. Okay, cool. So now we finish this line, and let's move to this line. Okay, for I starting from 0 to M. So here we have M as 7. We assign CI0 equal to 0. Okay, so initially we have I as 0, so it will be C00. Where is C00?
the first block.
Yes, over here. So we'll assign 0 over here. And next, so we increase I in the next one iteration. We increase I by 1, so it becomes C1, 0. Okay, so where is C1, 0?
The second block.
Yes, the second row. So basically, we're going to use the first number, first index as the row index, and the second value as the column index. So it will be in the row whose index is 1, whose column index is 0. So it is just right over here. We're going to assign 0 to here. Okay, correct? Correct?
Yep.
Okay, so next we're going to increase I again, so it becomes C2, 0 equal to 0. So we are basically going to assign 0 over here, and we're going to continue until I reaches 7. I reaches 7 is over here. So basically, we're going to fill in zeros over this column. Correct?
Mm-hmm.
Okay, and then next we have J starting from 1 to N. So N is 6. Sorry, so here N is 6, not 7. N is 6. Okay, N is 6, and then we're going to have C0J as 0. So initially we have C01 equal to 0. Correct? Where is C01? Here?
No, second column.
Yes,
Yes.
the second column. Yes, the first row and second column. C01. Okay. We're going to assign 0 to it. And then next, we're going to increase J by 1, so it becomes C02 equal to 0 over here and over here. So we're going to keep increasing J until it reaches 6 over here. So we're basically filling zeros in the first row of the two-dimensional array C. Correct?
Yep.
So why do we do that? Okay, so if we go back and look at this, okay, Cij equal to 0 if either I equal to 0 or j equal to 0. Okay, if either the row index I is 0 or if the column index j is 0, we assign 0 over there. So this is exactly what the first what is the first case of the equation ask to do. Correct?
Mm-hmm.
Are you with me?
Yeah.
Yeah.
Okay. Okay. So basically, we're just translating this case of the formula to pseudocode. Correct?
Yeah.
Yeah.
Okay. Cool. So then this is the first case of the this is the first part of the pseudocode. Any questions so far?
No questions.
Okay. If no question, then I'm going to continue. So I'm going to start. For I starting from 1 to m, and for j starting from 1 to n, if then we will have this. We will have a minus 1 plus 1, and then p Okay, so this is the whole part of the second part of the pseudocode. I'm going to write C over here. This is the matrix C. So I'm going to use a different color. Maybe use a red color over here. B and C. Okay. So so here we have two nested for loops. For I starting from 1 to m, for j starting from 1 to n. We're comparing x, the ith character of x and jth character of y, and do something. Okay. So let me write it in a better way. So this is upper left. Okay. So so here I'm going to write down the characters over the two-dimensional arrays. This is x, a, b, c, b, d, a, b. Similar over here, we have x, a, b, c, b, d, a, b, and y over here as b, d, c, a, b, a, b, d, c, a, b, a. Okay, over here I'm going to write say y as b, d, c, a, b, a. Okay, so here I'm just so basically each column, each row of the two arrays correspond to one character of x, and each row of these two arrays, each column of these two arrays correspond to one character in y. So that's why I write them over here. And then here we basically are using I and so we have m as 7 and n as 6. We're going to use I as the row index and j as the column index. Okay, so first if xi, oh okay, before I so okay, let's just continue for a couple of loops. First we have this. Initially we have I as 1 and j as 1, correct? Correct?
Yeah, in the beginning, yeah.
Sorry?
Yeah.
You can you hear me now?
Yeah.
Okay, so initially we have I as 1 and j as 1. Both of them are 1. I'm going to use a different color, purple over here, okay? So what is xi? What is the first character of x?
A.
Yes, we have xi as a. What is yj? What is yj? We have j as 1. What is yj?
Is it
The
B?
first character, yes, of y, which is b. So is this true or false?
False.
Yes, this is false. So we should go over here. Ci minus 1. So we should go to the if else statement. Okay. So Ci minus 1j larger than or equal to Cij minus 1. So basically we have I as, so here we're talking about I as 1 and j as 1. Okay. So we're talking, so now let's think about it. Okay. Ci minus 1j is basically C0, 1, correct? Correct? Because I is 1, so j is 1. So this is basically C0, 1.
Yeah.
Okay. So okay, we're comparing C0, 1 with this. Okay. C I j minus 1. So we have I as 1, j minus 1 as 0. Okay, basically we're comparing C0, 1 vs C1, 0. Okay, so where is C0, 1?
What, the second column?
Yes, over here, this is C0, oh, sorry. Oh. This is C01, and where is C10?
The second row, the one you just put.
Over here, correct? So we're just comparing these two values. Both of them are 0, so this is true. And we have this, Cij equal to Ci minus 1j. So we're basically assigning this value, Ci minus 1j, C01 to C11. So this line becomes this, C11 equal to C01, correct? Correct? We're assigning this value to C11. So this becomes, C11 becomes 0.
Oh, yeah, yeah.
And then similarly, we're going to assign, so we're going to assign the upper arrow to B11. So B11 equal to upper arrow. Where is B11? This is B. Where is B11?
The first one.
Yes, the first row and first column. Okay, so this is what we do in the first for loop, and then in the first iteration, and then next. So I'm going to, so we are going to increase j by 1. So j becomes 2. So we have x because I is not changed. So I is still over here. And what about so I is still a. What about yj? What is yj?
2.
It is the second one, which is d, correct?
Yeah. Oh, yeah.
Okay, so this is d. So we have xi as a over here and yj as d over here. Are they a match?
No, they're not.
No, they're not a match. So if it's not a match, we go to the if. We go to the else if. We are going to compare Ci minus 1 with and Ci minus 1j with Cij minus 1. Correct?
Yep.
Okay. So let me ask you one question. Okay. So if I tell you this is i's row and j's column of the array, or in a two-dimensional column, if this is I and j, if location is I and j, tell me, where is I minus 1j? Where is ij minus 1? Where is I minus 1, j minus 1?
Would the first one be 3, 4?
I minus, yes, this is I minus 1j. So basically it's upper, correct?
Yeah.
We go upper. Where is Ci minus 1j?
The other one would be at 3, 3. So it would be to the
Left.
Yeah, it'd be to the left.
So this is I minus 1, ij minus 1. What about I minus 1, j minus 1? Where is it?
It's to the left as well.
This is I minus 1, j minus 1. This is upper left, correct? Okay, so look over here, okay? So if you remember that, okay, so what we do is this. You need to, whenever we're trying to fill in value, you need to remember this, okay? I minus 1j is basically upper. You take the upper cell of the matrix or two-dimensional array compared with the left cell, which is ij minus 1, correct?
Yeah.
Okay, so we're comparing upper and left, and this Ci minus 1, j minus 1 is basically upper left, correct?
Yep.
Okay. Okay. So just keep those things in mind, and then let's come back to the pseudocode again. So, okay. So let's continue filling value. Okay. So here we go to the if else, and we have ij. We have ij over here. So next, basically, we're going to compare the value upper of ij with the left of ij, correct? Okay, we're going to compare the value to the above ij vs the value to the left of it. This is what this line tells us, correct?
Yeah.
Okay. So what we do here is that we're going to compare their values. Okay. So here it has a value which is also 0. Okay. This place also has a value 0. Okay. So so again, they're a match. So here we got a match. So we're comparing these two values. They're a match. So this is true. Then we're going to assign the upper value. We're going to assign the upper value to ij. Okay, the upper value is over here, so we're going to assign a 0 to it, And also for bij, we're going to put an upperward sign, meaning that this value comes from the upper cell. Make sense?
Yeah.
Okay, so next, we're going to increase j by 1. So according to this for loop, we're going to increase j by 1. So now j becomes 3. So here we have xi as a and yj as c. Are they a match? Are they a match?
No.
No.
No. So then we need to go to the else if. Again, we're comparing the upper value over here vs the left value. Okay, again, they're a match. So if it's a match, we just copy the upper value to Cij, correct? As what we did before. And then we're going to put an upper sign at the b, at the corresponding cell of b, meaning that this value comes from the upper cell. Correct?
Yep.
Okay. So next, we're going to increase j again to 4. And so now we have yj as a. Okay. So finally, here you can see that we have xi as a and yj as a. So finally, we got a match. So if it's a match, what we do is that we go to, so this is true, right? So this will be true. The if statement is true, correct?
Yeah.
Okay, so we are going over here. Okay, we're going to take the upper left cell plus 1. So this is ij, and the upper left is basically here. We're going to take the upper left and add 1 to it. Okay, and assign it to Cij. So basically here we are going to assign 0 plus 1, which is 1. And in the corresponding cell of bij, we're going to put an upper left to denote that we got this value from upper left. Correct?
Yeah.
Yep.
Okay. So then we're going to repeat. We're going to increase j by 1. So j is over here. So now we have xi as a and yj as b. It's not a match. So then we're going to go over here. Okay. Go to the if else. We're going to compare the upper value vs the left value. What is the upper value?
0.
What is the left value?
1.
1. So is this true of us? We have upper as 0 and the left as 1. False. So this is false. So we should go to the else. We are going to assign ci minus j to Cij. So basically, we're going to assign the because you can see here, ci minus 1j is cij minus 1 is basically the left one. So we're going to assign the left value to cij. So we're going to assign the left value, which is 1 to cij, and put a left sign in bij to denote that this value comes from the left side. Got it?
Mm-hmm.
Okay. So next we're going to increase j again, j by 1 again. So j reaches its maximum value 6, and then is it a match?
Yeah.
Yes, it's a match. So so if it's a match, we should go over here, and so we take the upper left value plus 1 to add 1 to it and put it in cij, and put an upper left sign in the corresponding side of b. Correct?
Yep.
Okay. Okay. So so here we just finish one. So we just let j reach its maximum value, which is 6. So then we should go to the outer for loop and increase I by 1. So now I becomes 2. So we have I over here as 2, and then we restart j from 1. Okay. So and over here you can see that according to the previous situation, you can see that what we do is that if the two characters x and I and yj, if they match, we basically take the upper left side value and add 1 to it and put it in the corresponding place of C. So we basically execute this: Cij equal to Ci minus 1, j minus 1 plus 1. Have you seen this equation before?
Yeah, it wasn't like in a math equation on the top.
Yes, it's just right over here. If xi and yj are matched, if the two characters match, Cij equal to Ci minus 1, j minus 1. So this line is actually exactly the same as the second case of the math equation. Correct?
Yep.
Okay, and then let's look at the else. Okay, so if it's not a match, we do this. If Ci minus 1j is larger than Cij minus 1, we assign Ci minus 1j to Cij over here. Okay, we assign it if it's larger than it. Okay, otherwise then it means that Ci minus, if else it means that this value is larger. So then we assign this value to Cij. So basically, it's the same as what we talk about over here. We're going to take the max between Ci minus 1 j and Cij minus 1 and assign it to Cij. So the else, if, and else are exactly the same as what we have in the third case of the math equation. Correct?
Yeah.
So let me simplify that. So we have this: if A is larger than or equal to B, we have C equal to A. Else we have C equal to B. So can we say this? If we have a if and else statement like this, can we say that C equal to the max between A and B? Can we see this?
Yeah.
Okay, so this is exactly what, so if you just replace Ci minus 1j with A, C, and Cij minus 1 with B, and so this is exactly what we talk about over here. So basically Cij is going to be the max value between this, the max between these two values. Okay, so this is what we do. And let's come back. Okay, so here we have I equal to 2, and so basically we have then we have B, so xi with as B and yj as B. So it's a match. If it's a match, what do we do? If these two characters match, what do we do?
Take the number to the left, right?
Yes, take upper left and plus add 1 to it. So because it's a match, we take upper left and and add 1 to it. So now I'm going to skip all the details. I'm going to fill in the values in a faster way, because we're almost reaching the end of our lecture. And in this cell, is it a match?
No.
No.
No. So we're going to compare upper and left and take whichever is larger to it. Okay. So here the left is larger. So we put a left sign over here. And over here, is it a match?
No.
No. So we compare upper and left. Obviously, left is larger. And over here, is it a match?
No.
No. We compare upper and left. So according to the algorithm, if upper and left are the same, we take upper. Correct?
Yeah.
Okay, so we take the value 1 from the upper side and put an upper sign over here. And then over here is a match or not?
Yeah, that's a match.
Yeah.
Yes. So we put upper left, match or not?
No match.
Not a match. So we take left because left is larger than upper. Okay, over here is not a match. So we compare upper and the left. Upper is larger. Over here, match or not?
No match.
Not a match. Okay, upper again because it's a dual. We take upper. Here is a match, so it is 2 upper left. Over here it's not a match. Left is larger. Over here is not a match. So over here it's not a match. So we take upper because upper is larger. It's not a match, so we take upper. Over here is a match, so we take upper left and add 1 to it. Not a match, we take upper. Over here it's not a match, so we take upper because upper is larger. Over here it's not a match, take upper. It's a match, so we take upper left and add 1 to it. So we got 3, and over here it is 0. It is what was that? It's left. It's not a match, so we take left. Over here, okay. So basically, we are going to fill in the values in this way. Since we are out of the time, so I'm going let me fill it. Let me fill in that because it's going to be more clear. So upper left. Oh, sorry, 2 and upper left. And 2 up. Say this is a it's not a match up. So upper. This is 3 upper. Okay, so A is not a match, so it's upper. D is not a match, so it's a match, so it's upper left. C is not a match, upper. It's a match 3. It's a match, so it becomes 3 upper left. And B is not a match. It's not a match, so it's upper. A is not. It's a match, so it's 4 upper left. And so here we got a match, so 1 upper left. D is not a match, upper. C is not a match, upper. So A is not a match, upper. B is not it's a match, so yes, it's a match, so left. So it's a match, so here is not a match, upper. Okay, so now we fill in all the cells of C and B. So tell me, what is the maximum length of X and Y? What is the maximum length between these 2 strings, X and Y? What is the maximum? What is the length of the longest common subsequence? Here, let's come back. Okay, if we're giving 2 strings, X whose length is M, Y whose length is N, and if Cij tells us the longest common subsequence between the first I characters and the first N characters, then tell me so in which cell can we find the longest common subsequence between all the characters of X and all the and all the characters of y.
Would it be at the last one? I think?
Yes, it is at CMN. It means that we're using all the characters from X and all the characters from Y. So here CMN is at the bottom right corner of the array C, and so this is 4 is the longest common length of the longest common subsequence. Okay, so some of you may wonder, okay, so what is actually the longest common subsequence? If you follow the directions in the table B, you will be able to find it. Okay, from the bottom right, we go up, upper left, up, upper left, left, upper left, left, upper left, and up. Okay, so this is the route, correct? This is the route for us to go from the bottom right to the top left to top left, correct?
Yeah.
Whenever you say upper left, it means there is a match. So the match is basically A, B, C, B. If you follow, you can also do it, circle it from the column from X. So we got B, C, B, A. So the longest common subsequence is basically BCBA, and its length is 4. The same as what we discussed in the beginning. If we got 2 strings, X and Y, and the longest common subsequence of them is BCBA. That's exactly the same as what we find over here, BCBA. Make sense?
Yep.
Mm-hmm.
Yeah.
Okay, so yes, this is the algorithm. And any question for me?
No questions.
Okay, so type in 1 if you think that you follow this example extremely well. You follow me and you understand the pseudocode. Just type in 1. Only say 1 0.5. Okay, another 0.5.
Yeah, I'm the same as them. Like
Okay.
I get it in the concept and everything, but I will have to watch it over again just so I can
Okay.
grasp the material, you know.
Okay, yes, I think yeah, okay, 0.775. Okay, thank you. Thank you for letting me know. Actually, this is really hard. If we don't have 2 sessions each with a 1 hour and 15 minutes, instead we have a 2-hour lecture or 2.5 hour lecture, I could explain this in a much better way. I cannot split the explanation of the algorithm in one day, in two different days, because you lose track of it. So that's why I go a little bit over time and go a little bit fast today. Okay, so if you don't have a very good understanding of it, just go over the video like later. And this is really important. And I hope that after you watch it, you can understand it, and you can realize the beauty of this algorithm. It's really beautiful. Yes, I agree. The time is crazy. I have an evening session today, which goes from 5:30 to 8, and usually so for me to explain this algorithm in that section, it will be much better because I have more time. I probably will spend 1.5 hours on this algorithm, but the students should have a better understanding. Okay, so but this is what we have. Do I teach? I say a couple of comments. Do you teach other classes as well? No, in this semester I just teach 2 sections of data structures. Next semester I probably will teach something like big data analytics and still data structures. So this is my favorite class. I desperately want to teach this class forever. I think I'm pretty good at it. so yeah, I also because I think this course is really important. So I want to teach that. Okay, so then if no other question, then that's the end of our lecture. I'm sorry for delaying, for extending our lecture by 10 minutes today. And so enjoy the rest of your day. Thank
Thank you,
you.
Professor. Have a good one.
You too.
Good one. Bye-bye.
Bye.